20 amp breaker can potentially handle both a household refrigerator and a small freezer. A typical household refrigerator draws between 5 and 10 amps, while a small freezer typically draws between 3 and 6 amps. To determine if a single 20 amp breaker is sufficient, the total current draw of both appliances must be calculated. For example, if the refrigerator draws 7 amps and the freezer draws 4 amps, the total current draw would be 11 amps. A 20 amp breaker is designed to handle a maximum of 20 amps of current. Therefore, with a total current draw of 11 amps, the breaker has sufficient capacity to power both appliances. However, several important considerations must be addressed. Firstly, ensure the appliances are plugged directly into the breaker, not into extension cords or surge protectors. Extension cords and surge protectors can limit the current flow and potentially cause overheating or fire hazards. Secondly, verify the manufacturer's specifications for the specific appliances to ensure they are compatible with a 20 amp circuit. Appliance specifications provide accurate information about their power requirements. Thirdly, if there is any uncertainty or concern, consult with a qualified electrician. An electrician can assess the specific electrical system and provide expert advice. To further elaborate, it is important to understand the function and limitations of circuit breakers. A circuit breaker is a safety device designed to protect an electrical circuit from overcurrents. Overcurrents can be caused by short circuits, ground faults, or excessive load. When the current in a circuit exceeds the breaker's rating, the breaker trips, interrupting the flow of electricity. This prevents damage to the wiring and appliances and reduces the risk of fire. Breakers are rated in amps, which indicates the maximum current they can safely carry. A 20 amp breaker, for example, is designed to trip when the current exceeds 20 amps. Exceeding this limit can cause the breaker to overheat and potentially fail. To ensure the safe operation of a circuit, it is essential to understand the total load connected to it. The total load is the sum of the current draw of all appliances and devices connected to the circuit. If the total load exceeds the breaker's rating, the breaker will trip. This is why it is important to carefully calculate the current draw of all appliances before plugging them into a circuit. In the case of a refrigerator and freezer, it is important to consider the starting current, as well as the running current. The starting current is the amount of current required to start the appliance's motor. This current is typically higher than the running current. If the starting current is too high, it can cause the breaker to trip, even if the running current is within the breaker's rating. The manufacturer's specifications for the appliances should indicate the starting current. If the starting current is not specified, it can be estimated to be several times the running current. It is also important to consider the voltage of the circuit. In most households, the voltage is 120 volts. The current draw of an appliance is related to its power consumption and voltage. The power consumption is measured in watts. The current draw can be calculated by dividing the power consumption by the voltage. For example, if an appliance consumes 120 watts and the voltage is 120 volts, the current draw would be 1 amp. When calculating the total load on a circuit, it is important to use the correct voltage. If the voltage is different from 120 volts, the current draw will be different. In addition to the current draw of the appliances, it is also important to consider the current draw of any other devices connected to the circuit. These devices could include lights, computers, and other appliances. The total load on the circuit should not exceed 80% of the breaker's rating. This is to provide a safety margin and prevent the breaker from tripping unnecessarily. For a 20 amp breaker, the maximum allowable load is 16 amps. If the total load exceeds 16 amps, the breaker may trip. If the breaker trips frequently, it may be necessary to reduce the load on the circuit or install a larger breaker. It is important to consult with a qualified electrician before installing a larger breaker. Installing a larger breaker without upgrading the wiring can be dangerous and could cause a fire. Furthermore, the National Electrical Code, or NEC, provides guidelines for electrical installations. The NEC specifies the types of wiring and breakers that are required for different applications. It is important to follow the NEC guidelines when installing electrical wiring and appliances. The NEC also specifies the maximum allowable load on a circuit. This load is typically 80% of the breaker's rating. Following the NEC guidelines helps to ensure the safe operation of the electrical system. Additionally, consider the age and condition of the wiring in the house. Older wiring may not be able to handle the same load as newer wiring. If the wiring is old or damaged, it may be necessary to upgrade it before plugging in new appliances. It is also important to inspect the wiring for any signs of damage, such as cracks, frayed insulation, or loose connections. Damaged wiring can be a fire hazard. If any damage is found, it should be repaired by a qualified electrician. Moreover, ground fault circuit interrupters, or GFCIs, are safety devices that protect against electrical shock. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. GFCIs work by monitoring the current flowing through a circuit. If there is a ground fault, the GFCI will trip, interrupting the flow of electricity. This can prevent serious injury or death. It is important to test GFCIs regularly to ensure they are working properly. The test button on the GFCI should be pressed to simulate a ground fault. If the GFCI does not trip, it should be replaced. It is also important to avoid overloading electrical outlets. Overloading an outlet can cause it to overheat and potentially start a fire. Do not plug too many appliances into a single outlet. If necessary, use a power strip with a built-in circuit breaker. Power strips can help to protect against overloading and surges. However, it is important to choose a power strip that is rated for the appropriate voltage and amperage. In addition, surge protectors are designed to protect electronic devices from voltage spikes. Voltage spikes can damage sensitive electronic components. Surge protectors work by diverting excess voltage to ground. It is important to choose a surge protector that is rated for the appropriate voltage and amperage. Surge protectors should be replaced periodically, as their effectiveness can degrade over time. Regular maintenance of the electrical system is essential for ensuring its safe operation. This includes inspecting the wiring, outlets, and breakers for any signs of damage. It also includes testing GFCIs and surge protectors regularly. Any repairs or upgrades should be performed by a qualified electrician. Furthermore, it is important to be aware of the signs of electrical problems. These signs could include flickering lights, trip breakers, and burning smells. If any of these signs are present, it is important to investigate the problem and take appropriate action. Ignoring electrical problems can be dangerous and could lead to a fire. When working with electricity, it is important to take precautions to avoid electrical shock. Always turn off the power at the breaker before working on any electrical wiring or appliances. Use insulated tools and wear rubber gloves. Never work on electrical wiring or appliances when you are wet or standing in water. Electricity can be dangerous, but it can be used safely if proper precautions are taken. To reiterate the main point, a household refrigerator and a small freezer can typically be plugged into a single 20-amp breaker, provided that the total current draw of both appliances does not exceed the breaker's capacity, taking into account the starting current and any other devices connected to the circuit. Always prioritize safety and consult with a qualified electrician if there is any uncertainty or concern about the electrical system. Following these guidelines can help to ensure the safe and reliable operation of the electrical system and prevent electrical hazards. Keep in mind the specific appliances and their power requirements, and factor in any other loads on the circuit. This will ensure the 20-amp breaker is not overloaded, preventing it from tripping unnecessarily or creating a safety hazard. Remember, electrical work can be dangerous, so it's always best to consult with a qualified electrician if you have any doubts or concerns. They can assess your specific situation and provide expert advice to ensure your electrical system is safe and functioning properly. By following these guidelines and prioritizing safety, it is possible to safely operate a household refrigerator and a small freezer on a single 20-amp breaker.